Well, hi, good morning. Thank you for joining me in my shop for, I think it's day 2 on this radio, although it was in my shop a couple of months ago for some preliminary checking out. Now, the way I remember it, back when very first time I checked this out on the bench, did not operate. And then I've had it in my listening area in my house here, and I've tried it 3 or 4 times, and every time it failed to operate properly. And what it does is it seems to go into like a motorboating or something like that is going on, and it's bad enough that it just seems like it's unwise to operate the radio. So rather disappointing, because it's a really cool looking radio. I have not been able to operate it, so I brought it in my shop here in order to sort out what's going on, find the defective part or whatever it is, and get the radio into an operating condition. But what I discovered yesterday was it works. What happened? How can this be? How can it be that it consistently failed to operate and displayed a somewhat dramatic symptom and would not receive anything? But here in my shop, it worked really actually quite well. So after yesterday's video was done, I discovered something unexpected. I've been operating the radio at 95 volts. Not the 117 or nominal voltage it should be operated at. 95 is fairly low. I wonder if I operate this thing at the proper voltage, will it display the problem that has been plaguing me with it since I acquired this radio. So that's what we're going to do. We're going to turn it on, and we're going to find out what it does with the proper line voltage on it. Okay, everything is just as it was yesterday, so we're going to try operating it with the 95 volts again. There we go. .95 volts, that's really low. So I'm starting it with the dim bulbs. There's no reason to. What I had done somewhat unintentionally, or I forgot I had done, I had turned down the supply voltage with this device and left it low and kind of forgot. So let's see what we've got here. We've got 89, 88, even lower. That might explain the low volume, yesterday. So this is full volume. Barely hear it. Okay, so we're on sideband. Can you hear that? Rumbling? .88 volt. Stupidly low. Let's take it down to a broadcast band and see if we can pick something up. There we are. WGR 550 from Buffalo. Now, did I not mention it? The antenna that's connected to this is a mini whip antenna on a pole in my beside my house, outdoors. Okay, so the idea here is we're going to raise the supply voltage and see if this thing breaks into some weird behavior. We'll see what kind of volume we get out of it also. So RF is full. I'm just going to cut it back a wee bit. And okay, let's raise it up. .100 volts. Getting a little louder. 108. Oh, look at that. Huh. Interesting. What's happening? That's interesting. Ooh, there's one pop. So that's the difference here. Let's go back up again, see if that starts. Take it back down. Okay, that's okay. It's not okay, but what do we do about that? Okay, well, interestingly enough, it's not such a big problem. It's wiped the radio right out. The radio is working even in the midst of the problem. Oop, there it goes again. Pop, 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 pop. Usually has something to do with the AVC. Let's make it pop again. And then I'm going to change the AVC speed. Let's get her popping here. That's what the AVC switched off. Send. Still going. Can you hear it? That's interesting. We can really hear the automatic tone adjustment in this volume. All interesting stuff. What else makes an effect? Some relationship between all these weird things? We're still on send. What is that? Oh, you know what? It's a dial lock. It's the dial lock for this. Is what it is. I'm not sure it's... Oh, look at this. Not the dial lock. It's moving. Can you see the point? You can't see it. You cannot see it. What I've discovered here... You still can't see it. Okay, I'm going to turn the set off because I think we've heard enough. Now you can see the indicating mark. See it go back and forth. So this is a fine adjustment on this. I guess that's what it is. Okay, very good. So what do we find out? Some weird stuff. Clicking still occurs when this is on send. Now, a certain portion of the radio is shut off when you move this on to send. Like the front end is probably shut off, no B+, or they may be fiddling around with the screen voltage when you put it into send. So that kind of might isolate this problem to a certain portion of the radio. Noise limiter affected it. Selecting the band here affected it. Okay, I think we're going to have to study the schematic a little bit, but I'm not sure I'd be able to nail down what is going on here. I almost feel that I have to apologize to you as a viewer. I've been staring at the schematic for a while myself putting it on the screen here. So this is the right half of the schematic, and you know, one of these parts could be the problem. Any one of these, and the other part of the schematic is here, and the large part, this part is overlapping on those two diagrams. So that kind of popping, I often suspect, is coming from something to do with the AVC system, and the AVC leads to a lot of motorboating type sounds. Now that wasn't quite a motorboating sound, that was a pop. So I don't know what to make of it, really. So what I'm looking for is the receive send switch. Receive send calibrate switch. It does three things, and I don't know the switch number on it. If you look at the power supply here, there's a switch right there. It appears to be interrupting the entire B plus output. That might be it. Operates with R6 and R15. What is this? OMG. Oh my god. What is this? I don't know what that is. It's an OMG. Maybe if we zoom in on it, it'll help. Think that'll help somehow? CMC? I don't know. It's not coming in. It's ganged to this switch. And this switch is switch number S what? It doesn't say. It just gives R6 and R15. Well, isn't there an S number that goes with this? Like S3? Well, maybe this is the switch. If it is, if this is the send switch, send receive switch, then when this is open, there's no possibility of B plus. Have I got this backwards? I've got this backwards. Jim, you've got it backwards. For crying out loud, they flipped the transformer around. I'm looking at this whole thing backwards. I'm thinking the plug is over here and the okay, so that's now the on-off switch. And what exactly this is, I still don't really know, but on-off switch. Okay. I'll be okay. I'm sure I will make it through this. So here's the B plus coming out of here, coming up here, coming over there, and heading off onto the other page. Here's the voltage regulator. I'm suspicious about this. Maybe the voltage regulator has something wrong with it, and once we raise the B plus high enough, this thing starts acting up. And what would it be? I guess breaking right down. Is that likely? I don't think so. I think these are really, there's nothing going on in these tubes. I think they last forever, but I'm not sure. So we could consider that as a possibility. An OA2, and I could do a tube test probably to prove that tube. And we're still external relay. Oh, here we are. Send, receive, and calibrate switch. So the idea is, how much of the radio does this shut off when we put it into the send position? I'm not even sure I can understand how they've done this. Switch. So here's the long contact, and there's no pointer after this and no pointer after that. See, there's a little pointer here and a little pointer here. But what are these two doing? I'm not going to make it past the switch here. Well, clearly something happens in the radio when you snap the switch from send to receive. Did they just forget to draw the arrows here? It must be the case. It must be the case. Not necessarily. get down to here, you snap it into calibrate mode. This is probably, this would be sending B plus somewhere over here, 4 lines up or 4 lines down. Either way you can count it. It's going up this way. No, it's coming along here, getting all the way into this thing. Oh, this is one of those, I shouldn't call it this, but integrated circuit. It's not integrated. It's not one piece of silicon. There's no silicon in this. Coming right over in this area, then this thing's all hooked up in here. Calibrator, here we are. Okay, so that all makes sense. And there's the 100 kilocycle crystal there. That's not going to help. Can that help? How can that help? Wow, I mean, there's a lot for me to learn here just to even understand where the possibilities could be for something like this popping sound. But not knowing much of anything and wanting to do something, checking this voltage regulator might be a good idea. You never know where the challenge lies when you're doing this kind of stuff. So here's my tube tester, and there's a roll chart down here, and I've been trying to roll the roll chart far enough back that I can read 01A, which is the tube 01A, I believe. And you know, I cannot roll the roll chart back any further. No matter what I do, I cannot uncover it. It's just back here. And I cannot find a internet version of the roll chart for this tester. So I'm going to stick another tester up there. Okay, let's try this. This is my favorite tube tester anyway. And I just reconditioned it. I put a new tube socket in here. So let's see if we can get the roll chart to show. Look at how nice that turns. I'm looking way over here. Oh. Uh-oh. Yeah, oh. I think it's 01A, wasn't it? Come on, you're not going to show it? Oh. Z4, oh. Whoops. Another one doesn't show it. Maybe it's OA1. Maybe I'm confused here. Let me just check. Because confusion does occur from time to time in my head here. It's OA2. OA2. Oh, there it is right there. OA2. Okay, so filament off. AP. AP. 05020. 05020. 0 on the bias. 37 on the English. This is important, I think, in this case, and I think this has to be set to English. Pressing P5 when it's time. Reads in the green. That's the test. That's not much of a test. I thought you'd be varying something, and you could see when the tube triggered, and then you could spot the trigger voltage or the breakdown voltage or whatever. Well, we'll run this test here. Next challenge is, you know how many tubes are in this radio? 18 tubes are in this radio. Oh my gosh, one of them is the OA2. But you want to bet's this one right here. I'm willing to bet it. Just pull it out and have a look. It's a bit of a weird looking tube. OA2. Right there. Made in the USA. Okay, so this is not your normal tube. This is a gas tube, and it's designed so until a voltage reaches a certain point, the tube sits there doing nothing, and then when the voltage reaches a certain level, it can't go any higher. Any extra voltage beyond that level just leaks through the tube. And then with the proper resistors around it, you can take advantage of that effect. So double checking now. OA2, the filament is off. AP 05020, 037, 0 and 37, set to English, press P5, reads in the green. It does, eh? Nothing to warm up, so I guess we just go ahead. Tube is glowing here. Reads in the green. Can you see the glow coming on and off? P5. Well, according to this tube tester, there's nothing wrong with this tube. And maybe my Bayesian instincts have failed here. Wow, well, that would have been great if that turned out to be bad. Well, I'm really taking a long guess that would be the problem. Well, beyond that, I haven't got a clue now what might be wrong with this radio. Just all kinds of things could be wrong with it. How to track it down? The first stage in troubleshooting is to localize the problem, and we've done that to some degree by discovering that when the set is set to send, the problem goes away. You know what, the problem may not go away. What may be going away is our ability to realize the problem's happening, because I'm basically shutting the speakers off when I do this. Or the effects earlier in the radio cannot reach the speaker anymore. So those effects could still be going on, we just don't hear them. That's probably more likely the case. You know, one of the things I love about doing this work is this puzzly part, which I'm in the middle of, or at the front end of right now. Puzzling my way through these problems is where I really get a kick out of it. As frustrating as it can be, and it certainly can be. You know, another approach here is just to get in there and start changing all the old parts. But there weren't a lot of old parts that would require changing, and I never take that approach anyway. I think that's pretty much slit your throat taking that kind of approach. I watched a video once. It was titled "Anyone Can Fix a Television." I thought, oh really? So I watched a little bit of this video, and it was a guy, the instructions were how to take out each, this is a modern television, not an antique one, a modern flat screen TV. You get the board out of it, and you start taking out every part one by one. You take it out, he showed you how to desolder it and take it out, and then if it's a resistor, how to test it, or if it's a capacitor, how to test it. And then after you test it, and maybe it's good or bad, you put it back into the TV. Oh my gosh, if anybody tried that, certainly if I tried that, when I'm done, there'd be 50 problems in that television, not just one. Okay, so we didn't really get very far here. What would be the next thing? Now, I tried to understand how much of the, right, let's just realize now, I just thought my way past that problem. Did any of that make any sense to anybody? Probably not. But I have this way, I don't know if it happens to you too, but I think through a problem there's a chain. And you think it to here. And then just now I thought the problem a little bit further, right? I was talking about the fact that you operate the switch, and maybe all that's happening is we can't hear the problem anymore. So I went a couple steps forward. Well, then I'm thinking about other things, and the next thing you know, I'm back in the chain down here, coming through again, and I meet up with the same spot. Oh, I already thought this through. Does that happen to you? Or is it senility setting in? It's probably senility. Early stage senility setting in. Well, I got to stop for a bit and think of some approach here. I've got to come up with an approach. You need an approach. So the question is, why when this thing is flipped to send does it stop making all that sound? And the extension of that question is, what is being cut off when you turn the radio to the send settings? B plus is being cut off from some tubes. Which tubes are being cut off? Now normally it's the front end tubes, but let's take a look. And see, so here's the switch here. Now I've looked at this for a while. I've decided what they did was they wanted to write send, receive, and calibrate like this. So they positioned it like this. So it gives you the impression that you snap once, snap again, snap a third time. Actually, only snap twice. It's only 3 positions. Whereas if they put the word send where it really needs to be, which is over here and over here, it would look more confusing. That's why I think they showed it this way. So if you look, the calibration, and this is B plus down here, by the way. So the calibration circuit only gets B plus when the switch is snapped over to here. And that turns on the calibrator oscillator we saw at 100 kilohertz crystal in it. But when you snap the switch, you are making connections over here. So here again is the B plus. This is after the voltage regulator, so this is regulated B plus here. So the switch is in the send position right now. I figure that because of the way this arrow is. So for the switch to go this way, it must be all the way the other way, and that would be the send position. And you can see B plus is interrupted to this. Now if you snap it to receive and calibrate, B plus will be connected here. So where's this going? So let's follow it to the left. Why does it seem completely different this time? I thought, am I following a different line here? We'll go up, up, screen. Aha. So I'll bet you these are all screens. We can't see here. No, this one's a plate. And a plate, two plates here. And go further along. Oh boy, don't get lost. Up here, up here. Off the top, down, and a screen. So some screens, some plates, it just looks like it's shutting off all these tubes here one way or another. Maybe not all of them, but most of them. Which is the... Now this wire was going the other direction too. It's going this way. Where's it going here? It's going down to here. So that's this one. That's 1, 2, 3. But I think we'll flip to the other page and look for R103, and we're looking at this line. Well, we'll see it all on the other page. We'll see it all on the other page. So here it is. So we're trying to follow out this line here. I'm going through a 5% resistor. And then here, let me just scroll up. Meter amp. Okay, does it go anywhere else? Did I lose track of it here? Did I make a mistake? I think I made a mistake here, didn't I? Not the calibrator. This line here. No, not a mistake. Plate on the meter amplifier. This thing has its own amplifier tube just for the meter. Going through, zero adjust. What is this doing now? This is going... Ooh, looks like they drew this line in late in the game, the way it's squeezed in here. From a drafting point of view, down, it's doing a lot of funny things, zigzagging around. Finally coming up to, oh boy. Okay, so the AVC switch. So the AVC switch was having an effect on this, wasn't it? Or was it not? I think I even turned the AVC off and it continued. I can't remember now. So, but here's an implication of what is being turned on and off. This is being turned off when I flip it on to send. So what exactly is being turned off? Everything here. all these lines. Oh my gosh, I'd have to print this out and color it up to track it all down. But it looks like it's cutting a lot off. What does it have to leave on? It doesn't have to leave anything on, really. because you're transmitting. Excuse me, and you don't want this to be operating at all, really. So you could just shut the whole thing off. Maybe that's what's happened. They're robbing B plus from everything. I don't know though. So the idea here is if the B plus is being cut in the front end of the radio, and the sound, the popping sound disappears, then you could assume the popping sound is coming from the front end of the radio. If the audio end or back end is left operating, I can't tell. There's no way I'm going to be able to track this. Not easily anyway. Just standing here, this is quite a bit of effort. What is that? Mute. Minus 80 to minus 100 volts. Are they saying if you put that voltage on this pin, you can mute this radio? Oh, that's a long wire. It's going everywhere. Right by the 10K there. Well, I don't know, man. I mean, wow, we're a long ways away here. Coming into a grid. 80 to 100 volts, negative. Some significant portion would make it here. You think that's what they're doing? So you're just muting this too? But this wire goes other places too. So that's a grid, signal grid. I'm not sure. I'm not sure at all. Okay, I didn't realize that there was such a thing though. I certainly don't have a 3 ohm speaker on here. It's probably 8 ohms at 1000 hertz. If you're interested, it's probably not exactly 8 ohms anyway. And that's not going to be related to the problem we're having. Wow, this is a very, very complicated radio, and I think the engineers are having a heyday in here doing stuff. Yeah. Wow. I don't know where to go with this. I gotta stop. I think I'm going to operate the radio again here, and I'm going to put the supply voltage down a bit so we don't get the effect. I have the lights very low in my shop, in case you're wondering why there's so much noise in the video image. The lights are very low. But I can make them higher. Okay, no noise. 104 volts. Can we make the noise show up? Like this. Apparently not. Wow. Wasn't expecting that to cut things right off. Okay. I have another Hammarlund radio, and there's a warning that if a particular capacitor fails, it will take out a component in the rotating part of the tumbler that's behind the switch in the other radio. And so if you discover your radio's not working and you start switching from band to band, every time you switch you burn out another resistor in it. Could that be the case here too? Something like that be true? Where'd the sound go? It's definitely some kind of tone thing hooked up to this volume control. Like a loudness control or something of that sort. It's like the audio bandwidth gets a lot wider. So it seems to me. At least it seems to drop lower. Nobody wants to pop here. Just looking for ways to make it act up. So we're at 104.5 volts supply. Popping. Okay, so I'm going to raise the supply voltage and try to generate the pop here. $110. No, it's not going to do it. 115. We're at 115 volts. Where'd the pop go? Where did the pop go? Hey, what's there? Some station. Quiet there. Something not right there. Is that the same stuff? Sounds different. So flip on the AVC, it starts becoming a regular pop. Flip it off, it's just a bunch of random noise. The noise limiter limits it, or turning this on kills it. We don't know. It is the kind of interference that a noise limiter is designed to eliminate. This would be fantastic if that's what's happening. It's a really good noise limiter if that's what's happening. Calibrate. No difference. Antenna. That's odd. I wouldn't have expected that. Let me turn off the antenna feed. Why am I turning off the antenna? Oh, there it is. Pop. And the antenna tuner have an effect on this. Okay, let's see if we can get it going more. Slow pop. That's pretty interesting. So that's a big hint there, changing the bandwidth. It would change the amount of signal coming out the end of the IF, where the AVC voltage is developed. AVC is switched off. Well, I'm willing to bet this has something to do with the AVC system in some way. Where to go from here? Let me disconnect the antenna completely from the back. Antenna's disconnected. Oh. Okay, it was not. I thought it went silent when we did this. What could be happening here is the B plus is varying. When I take the load off and put it into the send position, the B plus has changed a bit, and you get a rapid fire. Same thing with the supply voltage. If you raise the supply voltage, you raise the B plus, but not on the protected line. Not. Or is this thing rising up to 90 and then popping? Is this guy doing it? How could we tell? How could we tell that? We could see it. We can see it. Let's look at this tube here. Let me look at this tube. Is there anything we can see happening? So there's the glow. You see anything popping in this tube? I don't see a thing. So this is, well, it just doesn't seem to be anything happening there. I could pull it out. That would release the voltage it's controlling to go high, and how high, I don't know how high it would go. I could control that by reducing the input voltage, like the supply voltage to the radio, but then we're operating in such a different zone at that point. Right, and if the B plus goes up a little bit, let's crank it up just a wee bit. Here we go. Oh yeah, clearly. It's immediately responsive to the variations in the supply voltage. It'd be the rectifier tube? No, I don't think so. No, it's got to be something more in the AVC circuitry. Okay, this might have something to do with the B plus changing, maybe. RF gain. You turn it right up. It slows down. Audio. Audio, that doesn't change the pace of it at all. But the band does. The band does. The band did. It doesn't anymore. No antenna connected. With an antenna connected, this thing was sensitive to varying the signal coming in on the antenna. Wow, okay, that's a real mess. This is a mess of observations here. Not giving me a really good feeling. Ooh, new sound. Was that just a coincidence? I moved my hand and it. Yeah, I think it was. Okay, something you probably can't hear that I can hear is each time it pops, the noise level in the speaker, which is very, very quiet, but I can hear it, goes down. Goes pop, pop, pop. So I can hear the AVC system coming back from getting a shot. A shot coming out, we assume coming out of the IF. And then it's charging up the AVC system a little bit. It all says AVC problems, something. I think you can call this motorboating. I'm pretty sure, and the problem has to lie in the circuitry related to the AVC. Now there is one particular tube that is the AVC detector tube. Let's take a look at the schematic again here. So if we're looking here, plus delayed AVC. So delayed, I don't think it's delayed in time. I think it's delayed in voltage, and I'm not sure. I'm not sure what to say about that. In other words, if there's no AVC voltage generated here, there still is a voltage applied to those tubes. And so this thing's effect is delayed by this permanently existing bias. I don't know if that's true or not. So here we see the two diodes, and what else is, so they're both hooked right together here doing this thing, and this is going somewhere, who knows where, and this is also going somewhere else. Is this also the audio detector? It certainly looks like it. First audio dash delayed AVC. So first audio. Why did it say first? There's a second audio in here. Product detector. That's a different kind of detector. You know, when you flip this thing from AM to single sideband, you change detector. You hear the radio still popping? It's on single sideband. I'm going to switch it. Well, that's quite a change. Let's back over to and back again. So that's what it sounds like on AM. I'm just going to turn the volume down so we're not hearing it. Again, it's just all seems to come back to something going on with the AVC. Now, what could be going on with it? Jeepers. Bad capacitor. That's what could be going on with it. Wow. Okay, you know what? I'm gonna cut it here. for today, and then tomorrow we're going to look closely at the AVC system in the radio, try to understand its operation. Shouldn't be too complicated, and look at how simple the radio is, and see if we can't determine something about that, because I think the motorboating effect really points to AVC, and other things seem to be suggesting the AVC system is carrying the problem anyway, or I don't want to use the word amplify, but amplifying the problem, or making the radio sensitive to some problem, because the AVC is hooked up to the grids of all these tubes. So if something funny's happening in the AVC circuit, it's hitting the grids of these tubes. Okay, enough. That's enough for today. I wish I was ending on a happier note, but maybe not. Tomorrow we will look further into the AVC.